All right, today we are solving a conservation of momentum problem, and we are also solving a conservation of kinetic energy problem because we are told that there is an elastic collision. Elastic means kinetic energy before is equal to kinetic energy after. So this ball is moving. It hits another ball that is at rest. After it hits, ball A goes off at an upward angle alpha, ball B goes off at a lower angle beta, and we are asked for the final velocity of ball B, the angle alpha, the angle beta, given this information of masses and initial velocity. So here we go. Let's just get into it. So again, kinetic energy is conserved. That means that the total kinetic energy before equals the total kinetic energy after. We have the mass A and mass B with an initial velocity and initial velocity. And so afterwards, again, we have mass A with a new velocity plus the kinetic energy of mass B with a new velocity. Don't forget those squareds. All right, right off the bat, mass B is not moving to start, so I can just totally get rid of that. And then I'm just going to plug in my numbers, so 1/2. And I'm going to use kilograms instead, 0.26 kilograms for mass A. I'm going to pause, I'm going to write this out, and then I'm going to record again. So 1/2, 0.26 kilograms times 6 meters per second squared, that's the kinetic energy of A beforehand, equals the kinetic energy of A after plus the kinetic energy of B after, which is 0.58 kilogram times, uh-oh, I got a little sloppy here, VB squared. Okay, so now let's plug in the numbers in our calculator, and then let's come back and see what we... So the kinetic energy of A beforehand, 4.68 joules, is equal to kinetic energy of A afterwards, 0.8125 joules, plus 0.29 kilograms times the velocity of B squared. So we will take this, 4.68 minus 0.8125. I don't care about sig figs. I don't live in sig fig world. 3.8675 joules equals 0.29 kilograms times VB squared. And now what we're going to do is we are just going to divide by 0.29 on both sides. We're going to get 13.34 meters squared per second squared equals VB squared. We will take the square root of both sides. Square root answer gives us 3.65 meters per second is the speed of ball B after the collision. And the reason I'm going to say speed is I don't know the direction right now exactly, so I don't want to call it a velocity, even though the question was velocity. That is the magnitude of the velocity. All right, let's go look at how we solve for the angles. We are dealing with a closed system. So in other words, if I draw a box around mass A and mass B, there are no external forces acting on them, which means we are dealing with conservation of momentum. And if I have conservation of momentum, it means that the momentum before the collision of the whole thing equals the momentum of the collision afterwards of the whole thing. The trick to this problem is splitting it up into its x and y components. In the x direction, the momentum has to equal beforehand and afterwards, and in the y direction, the momentum has to equal the same afterwards. What do I mean by that? Well, to start, A is only moving, actually let me use red. A is only moving in the x direction. So in the y direction, the momentum is 0 before this collision happens. That means after the collision happens, the total momentum in the y direction must be 0 as well. In the x direction, the momentum is whatever the momentum of mass A is, which we will calculate. And afterwards, the total momentum in the x direction also has to be whatever the momentum of mass A was in the beginning. It's just that now that momentum is split up between mass A and mass B. So I'm going to write down some equations, and then we're going to come back and we're going to look at how to solve. So what I did here is I just said the momentum of A plus the momentum of B, x direction only, equals the momentum of A after the collision plus the momentum of B after the collision, x direction only. And the trick here is that after the collision, A has a total velocity, VA, that we found going off at some angle alpha. And it has two components, a y component and an x component. That x component is going to be VA cosine alpha, and the y component is going to be VA sine alpha. The same thing is going to be true for the mass B, it's just going to be with betas instead. So for mass B, I'll draw it out and then I'll erase it and we'll go back. But for mass B, that's going off in this direction with beta. This is VBX, this is VBY, this is VB2, and this is simply VB2 cosine of beta. And, well, again, I got a little sloppy and I ran out of room here. And this is simply VB2 sine of beta. Cosine means adjacent, so the adjacent angle. Sine means opposite, so opposite the angle. So adjacent is the one that it's touching, sine opposite the one that the angle is not touching. All right, I'm going to erase these. I'm going to go back. We're going to solve. Okay, again, the momentum beforehand in the x direction equals the momentum afterwards in the x direction, broken down into the momentum of A and the momentum of B. Beforehand, B was not moving. It has no momentum. It just goes away. Then what I did is I replaced the velocities in the x direction with the velocities that we know. We know the actual speed, that resultant velocity right there, and that at that angle alpha and that angle beta. We just don't know those angles. So I replaced them. Instead of saying VA2x, I said VA2 times cosine of alpha. Instead of saying VB2x, I said VB2 cosine of beta. So I resolved that resultant total velocity vector into its components in the x and y direction. And I did it on the y side as well. And remember, on the y side, before the collision, nothing was moving up or down. It was only moving in the x direction. So before the collision, the total momentum is 0. After the collision, the total momentum is 0 in the y direction. And again, I just resolved the total velocity into the y velocities only. There's a little bit of a trick you need to see here, though. I'm going to call it a trick, but A has a y velocity that points up, and B has a y velocity that points down. So it's really, really important that you take that into account and you put that minus sign here. You can put the minus sign on VB if you want, but it's really important that you recognize those momentums are in opposite direction when you go to solve this. So now all we're going to do is we're going to plug in the numbers and we're going to solve. So I'll pause, I'll start plugging in some numbers to save some time. I'll hit play again, or I'll record again. I have simply plugged in the masses and the velocities. I forgot to put in the units of kilograms, and put them in my calculator, and I've got 0.65 kilogram meters per second sine alpha minus 2.117 kilogram meters per second sine beta is equal to 0. I don't care about sig figs. We can talk about sig figs some other time. But so now all I'm going to do is I'm going to solve for one in terms of the other. So let's say I add this to both sides. So I say 2.117 kilogram meters per second sine of beta is equal to 0.65 kilogram meters per second times sine of alpha. All right. Now, I don't know, let's divide both sides by 0.65 or 2.117. It doesn't matter which way you want to do it. I'll do 0.65 on both sides. So it's going to say 2.117 divided by 0.65 is 3.26, good enough, kilogram meters per second. Actually, all the units cancel. 3.26 sine of beta is equal to sine of alpha. We have to do the same thing on the x side. We're just going to plug in all the numbers. So 0.26, I'm just going to write down what it all comes out to. 1.56 kilogram meters per second equals 0.65 cosine alpha plus 2.117 cosine beta. All right, my goal here is now going to be to isolate as well. So I'm going to do a little bit of rearranging, and what I'm going to do is I'm going to say 0.65 cosine alpha is equal to 1.56 1.6. I'm going to get rid of the units. There should be units here that say kilogram meter per second, kilogram meter per second. All the units cancel, so we'll just pretend they're not there for a minute. And that we already divided by them all. So what am I saying? 1.56 minus 2.117 cosine beta. And now we're going to divide by 0.65 all around. 0.65 divided by 0.65, so that we can say cosine of alpha is equal to 2.4 minus 3.2, we'll call it 3.26 cosine of beta. And as terrible as this looks, we're getting there. The next thing we're actually going to do is we're going to use trig identities to now solve this. And what I'm going to do is I'm going to take this entire thing, I'm going to take this entire thing, and I'm going to square them both so that I can put them all together. If you remember, cosine squared plus sine squared is equal to 1. So we're going to be using that idea in order to continue to solve this. So this is a pretty in-depth problem. So let's keep scrolling down, and let's do that next. Okay, so if I square this side, I get 10.63 sine squared beta equals sine squared alpha. I square this side, I get cosine squared alpha equals 5.76 minus 15.648 cosine beta. Minus times minus is plus, so plus 10.63 cosine squared beta. I did not like how sloppy that looked, sorry. Just going to rewrite that. Plus 10.63 cosine squared. All right, so now what we're going to do is we're going to combine the cosine squared alpha and sine squared alpha, and then we're going to combine the sine beta and the cosine beta. And if you remember from trig identities, sine squared plus cosine squared equals 1. So we're going to be able to use that identity to help us. We're going to put like terms all together. So what I'm going to do is I'm going to say cosine squared alpha plus sine squared alpha is equal to, I'm going to put all this together, 5.76 minus 15.648 cosine beta plus 10.63 cosine squared beta plus 10.63 sine squared beta. And this whole thing right here, we now get to say is equal to 1 because of our trig identities. And I'm just going to rewrite this other side equals, I'm going to write 10.63, and I'm going to put cosine squared beta plus sine squared beta minus 15.648 cosine beta plus 5.76. Hey, what did I just do? I combined these together. And look what happened when I combined them together. What's cosine squared plus sine squared? It's equal to 1. So I'm getting pretty close when I'm using my trig identities. And I'm now able to say 1 is equal to 10.63, because remember, these things just come out to 1, minus 15.648 cosine beta plus 5.76. I can now combine all my like terms. So I combine 5.76 and 10.63, and then I'll subtract 1 from both sides. We got to move down a little bit again. So now I'm able to say that 0 is equal to 15.39 minus 15.648 cosine of beta. Let's move this to the other side. So it says 15.648 cosine of beta is equal to 15.39. Divide both sides by 15.648. This side I will also divide by 15.648. I'm just going to erase it because I divided it by both sides. And now I get to say cosine to the negative 1 of 15.39 over 15.648 is equal to beta, and that's going to be my answer. So let's see what we get. I'm doing this in real time, which is why I'm a little bit sloppy about what's happening. I find that beta is equal to 10.4 degrees. Whoa, that was nuts. Now we have to go find out what alpha is. So we now know our angle beta. We have multiple equations that can help us find our angle alpha. What we need to do is we need to pick one of them and try to solve it. So let's pick, I kind of want to pick this crazy one, but let's say we pick this easy one, 3.26 sine beta equals sine alpha. I'm not going to go through what I get when I do arc sine, but what I'm going to tell you is when you do this, because you're going to plug this in, you're going to plug in your actual value for beta, you're going to find your angle of alpha, and you're going to find your angle of alpha is going to be, well actually, I guess I do have to do it in real time. So let's do it together. I'm just going to erase right here. I'm going to go back to this spot. I'll put a box around it. And I'm going to say 3.26 times sine of 10.4 degrees equals sine alpha. So 3.26 times sine of 10.4. I find 0.58 equals sine of alpha. I do my inverse sine function. So now I do sine to the negative 1 of my answer. And I find that alpha is 36 degrees. And that seems pretty good at first. But what's going to happen is if you check that answer over here and you solve for what alpha, and you try to plug in that alpha at 36 degrees, you're going to find something that's impossible. And the reason you're going to find something that's impossible is because the way that this elastic collision works, when that ball B gets pushed forward, it actually ends up resulting in ball A moving backwards in the x direction. And I know this all looks really confusing, so what I'm going to do is I'm going to go back and I'm going to check if our answer is correct by going back to our cosine as well, because what should happen is in the x side and the y side, our answer should work on both sides. And I'm going to show you what's going on here. So I'm going to go all the way back to here, and I'm going to plug in these numbers to try to solve. So I'm going to say 1.56, now I'm on my x direction, is equal to 0.65 cosine of alpha plus 2.117 cosine, and remember I found beta was 10.4 degrees. Let's plug this all in, right? So 2.117 times cosine of 10.4. Syntax error. Good job, me. Times cosine of 10.4. And I'm going to get 1.56 equals 0.65 cosine alpha plus 2.08. Let's subtract both sides. 2.08 minus 2.08. Ooh, we see something interesting here. We see a negative number. Negative 0.52 equals 0.65 cosine alpha. What does that negative mean? That negative means it's going to have to be the opposite direction. So now we divide both sides by 0.65. And I'm just going to erase here. Now we do our inverse cosine function. So cosine to the negative 1 of this whole thing is going to equal alpha. And I'm going to erase here, so that equals alpha. And let's plug it in. Cosine to the negative 1. Shift cosine to the negative 1 of negative 0.52 divided by 0.65. And what do we find? My pen decided to freeze, so I'm sorry, I have to do this with a mouse. We find an angle of 143 degrees. Now, we rounded various things as we went, so you might say to yourself, wait a minute, cosine of 143 degrees is not the same thing as, sine of 143 degrees is not the same thing as sine of 36 degrees. They're very close. Again, it just came down to rounding. 144 degrees, 143 degrees. It just comes down to how you round. But remember, based on the quadrant that you're in, if you're in the first quadrant or the second quadrant, sine is going to be positive, no matter what. But cosine changes from positive to negative. And the reality of what happened in this situation is mass A hit mass B. Mass A bounced backwards. And so it needed to have a negative velocity in order for the momentums to come out into equal. And I know that this was crazy, right? I did this in 20 minutes trying to record it. I hope it helped a little bit, even though it's a little crazy all over the place. But again, this is an advanced question when you have to use trigonometry to solve it, and you have to use your trig identities. I wouldn't expect, most questions to be this difficult in the land of maybe high school physics. So again, hopefully this was helpful. Reach out if you have other questions that you need me to solve. Check out my website, breezephysics.com. You'll be able to contact me there and give me ideas for new videos.